Hey everyone, welcome to my channel. Hey Vijay, hey Akshay, hey Kalan Krishna. Thank you for being with me, and let's get started. So today's session is very interesting one. That is containerization. Now I think you already heard. I think most of you already heard about what is containerization, what it does. I will be talking about everything from the beginning, so don't worry. Hey Chirag, what's up? So so let's get started. Okay. And today's session, I'll be not just showing you some demo or anything. I'll be discussing in depth about all kind of coordination concepts, what kind of design pattern you should follow, what kind of application architecture you should be, building with, load balancing, and there's a lot of stuff. Right? It's not just about simple things. It's complicated. Anything you want to have production level it could never be simple. Okay, it's gonna be complicated. Not now, maybe later. It's gonna become complicated because when I start actually, I started with small projects, just maybe 1-2 API at the beginning, sign up or login, just the user base. Slowly, new API get developed, and slowly things get started more and more, and it become huge project. Now, why should even you use the containerization? That should be the first point to discuss. But before going that, let's let other also join the session because I also didn't share in the LinkedIn yet. So let me share this link with LinkedIn so that everyone can join. Just a moment, it will not take much time. Also, in the meantime, if you have any kind of questions, you can go ahead and ask in the comment section. We could have any kind of questions, right? Regarding containerization or maybe application architecture. Any question, if you want to ask me, just go ahead and use the comment section. I'll be answering them all. Okay. Just let me share this link with others so everyone will know that I've started the session. It should not take much time. Okay, let me share very quickly. Also, about the containerization part, if you want to, I have already covered ECS, Docker. There is separate playlist in my YouTube channel. Go there, you will see more in-depth videos. Okay, this is fundamental session. So I'll be talking about fundamentals, most of the use cases, how to do simple things. But more advanced sessions are already pre-recording in the Docker sessions. There's a playlist for Docker, and there is for ECS. There is also a playlist. So go there, and we'll see all the sessions. No problem at all. Okay, and it's more in-depth covered. Okay, this is I'm saying it's fundamental, but those sessions are very most advanced sessions. Okay, now let me just share it pretty quickly so that other people also can join the session. It should not take much time. Okay, just give me 1 minute. Again, in the meantime, if you have, I know you have many questions. You ask me in the normal LinkedIn, comment section. I thought I will answer them, but I get busy and I can never answer that. I missed a lot of comments. Okay, so since I'm already in live now, you can go ahead and ask me the comments. I think there is a comment available section where I can see the live comments, so I can just see an answer. Okay, done. So I've shared the link in LinkedIn. Now I can get started. Okay. Now, so Chirag is saying something that it's a favorite topic. So yes, containerization is one of my favorite topic. That's true. Because what I'm saying is, I also talk about, I will start sharing my when I started with this containerization and all. So it's around, I think 4 years back or 3 or 4 years something back, I started with playing with the Docker containerization and all. That time I had a project. Actually, my client asked me, Sandip, we want to run an application and we want to make it password encrypted, but make sure that no one else can access the image. That kind of very weird requirement we had. So we have to ship the project in a containerized form, like in a Docker, and that one others should not be able to log in properly. Okay, so they cannot do SSH without any password. So it has to be password protected, and the application itself has to be running in a Node.js application, and there has to be IoT kind of data flow going to happen. That was the use case around 3-4 years back. Okay, then I started with the container Dockerization. Now, how things worked, how things go on. So when I first started the project, I First, I'm using normal Docker inbuilt images like you have available in Docker Hub. There you, if you go to Docker Hub, let me share the Docker Hub link also. It will be good for you. So if you want to play with Docker, first go to Docker Hub and see most of the images are already there. Okay, so you can just pull the image and play with it. As very quickly you can play with it. I did the same thing. So this, I just share the link. Give me a moment. So this is hub.docker.com. If you go there, and you will see that all the pre-built packages, pre-built images are there, which are community provided, or the main software company is already providing. Just go ahead, like you can get for Nginx, you can get for Python, you can get for Node, you can get smaller packages like Alpine. Most of the things are there. You just have to use that image as a base image and do it. So at the beginning, when I was done, I was like hopeless how to do it, how to do things. That was the pretty basic thing I had in mind. So I get to know I have to make a Docker file. First, I was using the basic images just to run the application and all, like Mongo or maybe Redis, just to keep the app running. But now I had requirement to make it password encrypted and make sure the inside content or the application logic or the application code must not be accessible to the third parties. No one should be able to access. That kind of requirement I had. So I did that way. We ship the application like password encrypted from, it should be Dockerized. So we did it finally. And then there was further requirement that we want to run multiple container application. We want to scale based on the containerization instead of the instance basis. That was also a very good use case. Then also I used the Dockerization. So this is how the things get processed. First, basically we started with the Mongo or Node, then slowly the password protection, then slowly scaling. So this kind of requirement came. Now, if you ask me that Sandip, I have a project, should I even go for the containerization? I will ask you two things. Is the application need to keep running? If yes, is need to keep running, then think about containerization. If you say, Sandip, this project is not going to keep running forever, it's like people use it and then people don't use it for a while, and then people again keep using it. There is intermittent usage is there, right? For this kind of use cases, you have to go for serverless. That will save you huge cost saving. That will do huge cost saving. Trust me, I am running a project where there is no cost at all. I mean, that's free of thing, and that's a production application. People using it for a certain times, and then when the thing's done, that's it. That's done. And since Lambda have some lakhs of API called free, so anyway it's free. Only even email, there is some email sending logic also, but that also free because 65,000 emails is by default free from AWS. So there is no cost at all. So this kind of where you don't have the requirement to run the application and keep running, use serverless. When to use this kind of containerization project? When you have complex packages and all, you don't want to install in a machine again and again. You don't want to have the installation time, because if you go for normal deployment, you will see you first need to reinstall the packages. You have to do some kind of testing stuffs and all, but that takes time, isn't it? Maybe a few seconds, it could take few minutes. You don't know. I don't know, right? Those kind of cases is yes. Those kind of uses, containerization is a gift for you. Think about it. When you're building the image, you can, when you're making the Docker file, actually, I will give you an example of Docker file, don't worry. So when you have running Docker file, there you are actually building the image and you are doing the testing also. That's called multi-stage build. I will give you an example. I think there's a lot of article. I will just show you any good one. Don't worry. But think about it. You are doing the build of your building application. You are doing the running testing, and then ultimately, if your application is working fine, you have your test cases there. You are doing that good, right? Isn't it? That's how good it is in the containerization part. Now, before containerization, what we did, what we used to do before containerization. I was using this kind of server for a long time. I didn't have the containerization logic that time. That time I was also, I think I'm using EC2. And what we did was I was using AMI images, Amazon Machine Image. So what I did in a EC2 instance, I install all kind of softwares and do everything. Then run the application, do testing, and then I did all kind of stuff. Then I make a AMI image, Amazon Machine Image, and I use the same image for other instances, right? But think about it. the new instance to come up and running, then again installing the softwares, installing other things, it's taking time setting up, isn't it? Now if you use Docker, then Docker itself is the complete already dependency is installed, application is all set, your everything is there. You just need to run the container, run the image in a container, and that's it. There is time savings, there is less downtime, because the more downtime you have, the more customers you will face, right? Isn't it? The performance problem will face. But if there is less downtime, the more better for you, isn't it? Think about that way. You can save time, you can save money, and you can save your customer. That's a more customer centric solution. This is. So think about all these kind of things when you're going for the containerization part. And there is, of course, there is a very common term that this run on my machine, this doesn't run on your machine. That's a very common term people used to say. Even I used to say a lot of time to the beginning of time, like customer asking for Sandip, why is the project is still not set up? I mean, it's literally done, right? Isn't it? So why are not able to run? I mean, people are running, why you can't run it? Say I'm running Linux machine or Mac and they are running Windows. The problem is that running fine in their machine, the Windows libraries, Windows, everything is there built up. Now it's not running in my machine. I'm like wasting my hours and hours. Why the hell the project is not running? I have to give them some briefing, some suggestions, some kind of feedback, but the project doesn't run. So this kind of situations happen and crazy. Now if they use the Dockerization that time, I just use the Docker. I'll just pull the Docker image. I will run in my local machine. Virtualization is anyway same thing, right? If they are running properly, it should run in my computer also properly. It would have saved my lot of time. So in the perspective of development scenario, when you have large teams, then also good thing, right? So things running in other computer, other people Docker engine, it should run in your Docker engine same way. So no problem at all. That's good it is. Now, this is not just the use case. I was talking about the basic use cases. I'll be coming most advanced use cases with respect to AWS. Now, why even you go for AWS to use run your application? But you can run in any machine, right? You can run in local machine or you run in your any other cloud provider also, isn't it? Now you can run in other cloud provider, but they can't offer you, or they might not offer you as agile or as vast solution AWS already has. I use other container also, but I like the AWS more. Sometimes I like both places. I have like multiple running for multiple cloud providers, but that's a complex solution. If you are just starting with, or maybe you have a running application, you're a mid-level firm, you cannot handle all this kind of complexity, maintaining this multi-cloud architecture and all, right? You just want to run your application to be basic, and then later when it goes good, then you hire big engineers and do all kind of big stuff. But till then, you can run in your AWS. You can run all your workload in AWS. Think like that way. So I'll be coming there. What kind of solution AWS provide? What you can do. Now, at the beginning, I say that if your application doesn't need to be run, all the time, then you should use the serverless services like Lambda, something like that. But if you want to run as a containerization, like there is multiple complex software need to be run in the container. Sometime in Lambda, you will face problems if you want to run this kind of complex things. It takes time, kind of long running stuff. There's problem because Lambda has 15 minutes timeout, and now it's maximum. Previously it was 5 minutes, now it's 15 minutes. But there was a timeout, right? You cannot keep it running. But you have a requirement that the app should run for at least say 1 hour, 2 hour. Now Lambda is not a solution. You have to keep it running for 2 hours, 3 hours. Could be long process, batch processing. Now you don't want to use the normal EC2 instances. You want to make it more dynamic way, like make the Docker up. It do the processing. Once it's done, close the Docker, close the container. That way, you can do it using AWS Fargate. So AWS have solutions, multiple solutions. The famous one is ECS, and ECS you have normal EC2 instance-based application running. ECS-based architecture and the Fargate architecture. In Fargate architecture, you can run for when it's required. When the running is done, your processing is done, you stop the container and you will have no billing at all. That kind of solutions are there. So you're thinking about, okay, I have this kind of way, I have to keep running for 3 hours, and then but for that you don't have to keep instance keep running, right? You can just simply run inside a Fargate. I will show you everything. Just give me some time. I will start the sharing. Give me one moment. Also, yeah, also remember that let me share actually, I have a playlist for Docker and I have a playlist for the ECS also. So just let me share the links. Playlist. So let me give you the Docker playlist first. Okay, learn Docker with Sandip. So I'm giving you the Docker playlist. Docker playlist. So yeah, so I have a playlist for in Docker already. There is there in Docker. I have covered. Let me see what I've covered in Docker. So I have like why and how developers should use Docker, build basic image, build basic Docker image using Docker file, Docker basic commands, getting started with AWS ECS dynamic port mapping, and okay, that is the ECS part, but the basics are covered. So you can just go from there. And also let me share about the ECS. I will give you some demo. Just wait for a few minutes. ECS playlist ECS. ECS. Okay, and this one I'm giving you for ECS. AWS ECS playlist. So I have for ECS also. So if you go there, you will find all the sessions already pre-recorded there. You can follow up without any issues. Okay, you can go there. Now this is there. You can go anytime and you can explore anytime. Now let me share the screen and go through all this kind of stuff. Okay, that will be much better, right? You can anyway go there, and I mean from the playlist you can go. But let me share the screen. Share screen. Give me a moment. Sharing the screen. Okay, share screen. Application Chrome tab. Okay, so let me know if you can see the screen. Just confirm me that you can see the screen and no problem at all. That'll be good. I will show you the from ECR what you have to do, from ECS how to do. Now all the sessions are already there. You can go there and watch. But let me go through like overview kind of stuff. Okay, so AWS have solution. If you go to AWS ECS, now you can run a simple EC2 application. I mean, sorry, EC2 machine, and then there you can install Docker and you can run your Docker images. But then you're handling all this kind of complex stuff, isn't it? And you want to, as an application developer, you have the you should be thinking about how using less time you can do more things that way. So that's why AWS have ECS. Let me show you ECS, Elastic Container Service. There where you basically just have to create the cluster. Now let me show you where you have to do the the intelligent thinking part you have to do. Now see the screen. You have networking only, EC2 Linux networking, and this one. Now only for the networking only here powered by AWS Fargate. This one is for normal one. Here, if you want to just run the Fargate cluster, if you want to create, go for this one. If you want to run, like suppose you have an application that need to keep running and keep running, then go for this one. If you want to just like sometimes if there is requirement, sometimes there is no requirement, then go for the network only part. That is a Fargate solution. Okay, choose based on that. I have already created an because it takes some time. That's why I'm saying I've already recorded session where you can go and check all the session I've already shared. For ECS, we have this one. Just go and after the session you can go. I will be ending session just within 8:30. So after that you can go and check. Okay. Now this is the part where you will be creating the. So let me create this one because this one doesn't cost me, right? Let's say cluster. Say test cluster. Here VPC new one. And the default is there. Enable container insights. So you will have the logics there. It will take some time, to be honest. That's why I was not going to show you because I've already pre-recorded sessions. But anyway, let it run there and let me explain more things about what I have to do. Now, You can see that I already started there. Now let it take some time, and till then let me tell you that that is the cluster creation page. Now suppose you have developed image locally using, it could be your any kind of application logic. Now after the application is you are done with the developing your image, you have to upload the image in the somewhere. I mean, you have to upload image some other, as how you can use the image in as a in AWS ECS or in the normal EC2. You have to you need to put it somewhere, right? Otherwise there is no use. For that purpose, you can use the Docker Hub, because Docker Hub, that is official Docker's own thing. You can host there as a private repo, and then you can use that in AWS ECS or anywhere. That doesn't matter. You can use anywhere. And suppose if you don't want to keep in Docker, and you are already, you see, have some credits, or maybe you want to keep the billing in the AWS EC, I mean AWS itself, or just the billing, you want to keep everything in under AWS account. Now you don't want to put things here and there. So that cases, let me show you the ECR part. Chrome tab, ECS. See, the cluster is also created. So I will show you. I will just run a Nginx image and show you how things works normally. Now let me show you the ECR ECS. 1 minute. Okay. Now here is the ECR part that I want to show. So after you are done developing application, you can just go here and create repository, like name it sample sample image, sample repo, whatever name you want to give, then create repository. And if you click here, you push commands. So normally what you do, you build your image, like whatever image you have in a Docker file, and after that you just tag the image with this Docker URL, I mean this ECR URL, and you're pushing here. After you push, it will come here. In my past session, you can see that, no problem. After that, if you go to ECS cluster, suppose you have whatever cluster running, like this cluster, you go, there's a task definition. You have to go to task definition and create task definition. Suppose for Fargate, EC2. Fargate, it doesn't matter. You can use the same image in any. So just give some like this task something, doesn't matter. See, if you use the Fargate one, you have only AWS VPC. But if you use the normal networking, I mean not normal EC2 based one, you will see like host mode, bridge mode, those kind of modes you will see. Okay. You can just mention like what kind of, how much you need, like on CPU, doesn't matter. So this is the part we should be worrying about. There you have to give the container name, like say sample container. And this is the part where you have to mention the image. Now you remember we build the ECR part there. That image you can use here. And as I told you, you can use the Docker Docker image also. Suppose I want to use the Docker image in Nginx, because it's the widely used one. Like you can say any demo purpose, I use this one for. Okay. Now this one is a public one. That's why I'm just giving directly. If it's a private one, come here and you can just secret manager. You can do all this kind of stuffs. Not a problem. Okay. Or in the URL, I think there is some way in the URL itself you can mention the authentication part. Okay. Here, suppose I want to do port map with 80 port, and then add it. If you want to run, just create it. Now, invalid characters. Okay. Family. Oh, sorry. Okay. Sample task. And let me see. Let me try to create again. Okay, done. Task definition is done. Now go to cluster and click on the cluster. You can see tasks. Run new task. Sample task is there. This cluster, number run. I don't need anything. PPC, the newly created one. I think this one. Subnets, you can select all this, whatever subnets you want. You use it is a security group. You have to allow the port 80 is already allowed. Now auto assign public IP, you don't need normally. Okay, and then it will balance speed. Just run the task. Before capacity provider. Okay. Something error. Cluster capacity. Sorry, Fargate. Okay. Done. So this is how easy it is to run. And we will, after that, you will get the other things to public IP you are getting already, right? Just use the public IP. Is in the pending status. When it's active, you can just go to the IP and you will see the application is running. That's how easy it is. Okay. Now this is one to show that how easy it is to do via the AWS ECS. Now AWS have more than ECS. It have EKS. Now I think most of you already heard about all this kind of buzz stuff in EKS and all. EKS also have a session. I'll be sharing the link. Give me one moment. I think I have to put an updated one because that one become older. Yeah, I think already maybe 1 year back I did the AWS ECS one. I don't remember right now, but I will make again another good EKS session. But till then you can give it as a reference. I have a document also there. So AWS EKS. Like see, you have Kubernetes. In Kubernetes, you run your Docker images. Amazon is not doing anything. They're doing extra, but not that huge. I mean, they're certified provider, right? So whatever Kubernetes support, they will be supporting the same thing. That's how easy it is. Okay. Now here's the logic is that the master nodes will be managed by the AWS, and they will be charging you around I think $65, around 70, something like $65-$75, some kind of cost. That is a fixed cost. Even Google is also running. I mean, they are not doing for free. Previously they're doing for free, but now they are also charging. So no one doing for free. Okay. Now you can go create a EKS cluster. Master node will be free, but any kind of worker nodes if you want to run, it's not free. You have to pay for them. Now, what will be the cost? Think about it. The cost is EC2 type you choose. That will be your cost. As simple as that. Not only on demand, you can select for that spot instances also to reduce the cost. Now, strategy here I will be suggesting that use 50%, maybe 60% as a reserve. I mean, normal instance or reserve instance. I will say if it's a long running application, and rest of the things run as a spot instance to save the cost. That way you can save huge cost. Okay, that's the strategy I used personally. So you want to use it. That way you can save a lot of cost. Okay, I think I'm using savings plans also. Some cases, see, not all kind of clients are same. Not their requirements are same. Everyone has their own kind of requirement. So think about that. As per the requirement, choose a solution. In service, why you choose Fargate? Why not you create task with for? Okay, we explain. I don't understand. So that's okay. So in service, I use Fargate. Now Fargate I use because I just want to show a demo. But if you go in my that I shared in the other links, if you go to this ECS playlist, in this playlist, if you go, you will find all kind of examples there. I am showing you now. Fargate is why. Suppose you want to run an application for 3 or 4 hours. After that you don't need to run anymore. Task done, automatically the container will close. That cases, Fargate is fine. The billing will stop there. But if you keep run instance after, I mean, like a normal EC2 instance you are running, and inside that you are running a normal container, a normal Docker image. Even if you stop the image, the cost is not going to decrease because ultimately the machines are running, right? The cost is going there. So that's anyway you have to pay. So think about it. Why use the Fargate? You want to run like for a few hours. After that, it's done. Then Fargate. If it's a keep running application like for long or maybe months, years kind of thing, then go for the normal networking based one, the normal EC2 based one. Okay, that is the difference. Okay, and let me. Okay, that I was EKS and then I got here. Okay, sorry. So EKS part, I'm saying that EKS part. Think about the just if you have big image and just don't go jump in the EKS. Think about making it smaller and smaller. Think about the inter-networking between the containers. Ultimately, you have to do all the stuff. Normally, EKS, what did you have? You are developing the microservice application, right? So you have to refer the application by the logical names or kind of complex stuffs, right? Think about that. Make your application performance proper. You go EKS, you go whatever the world has to offer, but the application, if it doesn't work, no use. So first, make your application more performance, more optimized, then go for the solution like EKS or ECS. Now, if you don't want to go for all these kind of Kubernetes complexities, then I'm just simply saying you close your eyes and go for ECS. If you know how the Kubernetes ecosystem work, you know how the ingress traffic or exist traffic, the outgoing traffic works, how this service concept, what are the cluster IPs, this kind of complex, or maybe the role-based access management, other steps like service-based deployments, the YML file creation, all this complex stuff. Okay, pod management and stuffs are there. If you are okay with it, then only go for the EKS. If you are not feeling comfortable, just getting started with the Docker and containerization, you want to use the Docker, to run production level application in as a container application, then go and use all this kind of stuff in ECS. That's simple it is. If you have the knowledge Kubernetes, all good. You want to pay for $65 like as a month, like a mandatory one, then go for the EKS. You don't want to pay that much. You want to run like small or medium workload, then it's okay. Just use the normal ECS. I mean, ECS is it's not costing anything, right? It's when it's costing when you are running any particular application ECS. That's it. That's easy it is. Now, if you have any kind of questions, something bumping up in your mind, you can ask me. I have a lot of time. I'll be talking a lot of more things, but I'm open to accept any questions. Like what Vikram said, that was a very good question. Why use the Fargate? Why not use the normal one? That was a very valid one. So if you have any kind of questions in mind, just go ahead and ask me. No problem. Okay. Now the thing is, I'm showing. I told you that I will show the multi-stage build. Okay. So let me find a good article on multi-stage building. What I'm saying. So Docker multi-stage build. Okay, let me. Actually, Docker they themselves have a very good documentation. So let me show that only. That'll be good for you for a good example. Okay, that was good. Okay, Chrome tab multi-stage builds. I'll be sharing the links also. So if you don't know the Docker multi-stage build, must study what is Docker multi-stage build. It will save you the time. It will save you the cost. It will make your performance better. Think about it. So Docker multi-stage build. I'm giving you the link. Give me one moment. Okay, so this is the link. I have already pasted in the comments. You can just click on. Don't go there right now. I'll be showing you anyway, right? So don't go right now. At the end of the session, you can go ahead and explore. Okay, no problem. Now here they're giving you some example. Just think about very quickly. Multi-stage build. See, most challenging part is the Docker size. I mean, if you're installing a lot of stuff, a lot of dependencies in a container, which you actually don't need, to be honest. You're doing it, but you don't know, you actually don't need it. That case is actually, this is very important. So just pick what you actually need and leave behind what you don't need. So ultimately your final build image will be smaller, performance, less space taking, and it will ultimately take you less cost. It will more agile application development architecture that way. Okay, that's what I'm saying. Always think about the multi-stage. Now I'll be explaining what is multi-stage build is. Now think about the example. This is a Docker file, sample Docker file. Okay, you have a like your application app.go. You are just doing all kind of stuffs and installing all kind of stuffs. Like you are sending a work directory, like a default directory, and doing all the stuffs. This is a Docker file. Like from now, it's a Golang default image is a bigger one, I think. Okay. Now you have the Alpine. There's a very smaller image. Now this is a build stage, all this kind of complex stuff going. So make the final build using multi. See, this is a multi-stage build example. Good one. So from the Golang image, we are just building all kind of complex stuffs. Okay, we're just building it. Okay. Now there, if you see the Alpine, now Alpine is a small image. That's why people use it to kind of like necessary stuffs are there, but it's small image. There you just API carrying no catches, CA certificates. Then you are setting the root directory, or you can set any directory. Yes, in your root. You are just see here from the work directory from 0. Yes, I think you're not doing it. In the end they will be doing it. So they're doing it. They're actually running it, and work directory they're setting it and running the main application here. They're doing it like this. That is also multi-stage build. Now spot at a specific build stage. Target, latest, use external image as a stage. See from like if you want to run in as an Nginx image, see they're doing it like from Nginx, Nginx configuration to this configuration. I mean your final local configuration to this configuration. You have to do this kind of stuffing. Use previous stage as a new stage. So you can do this kind of complex stuff. Now, why I suggest these things? Because it's the basic example, to be honest. It's not that complex, but think about this. Ultimate, after doing this, your image will be smaller. You can do a lot of stuff. Let me give you another example. I found an example. It was a very good one. Bits and pieces. Let me see. I found a very good example. I have the link. I don't know I have it right now or not. Okay, let me give me some time. Yeah, found it. That was from using Node.js because I'm a Node.js developer ultimately, right? So that's what I wanted to show you. This is the link. Another multi-stage build post link. So check this one also. Since I'm Node.js developer, I wanted to show you this one. This one. Let me just share in the normal screen also, so I can show you. Why I'm showing this, because this is important in the practical life, in the normal day-to-day development life, you will need it. That's why it's very important. If you go to any interview and interviewer asks you what is a multi-stage build in like a DevOps job, you go and they ask you for the Docker, you can't answer. That's a very bad situation for you, to be honest. You know, if I take interview, I ask developers what is multi-stage build. Someone else can ask you the same thing, isn't it? So learn this kind of stuff. Now you don't have to know everything, but learn the basic stuff. That will be enough for you. See, they're using Node.js build image. Let me show you the final one because that will be easier one. From Node, where is the final one? So here also example they're showing from Node.js build. Then they do it. Just use they're using one for building and then copying from there and just doing. This is also a good way to make the package smaller. You can do this way. There are a lot of articles. You just go to internet and do this, search about this kind of articles. You will find a lot of articles like on the multi-stage build and all. Think about it. There are a lot of things you have to explore. In Docker, you have this. You have kind of you can do multi-variant environment variables management from the normal files. You can do like suppose in a Docker container itself, you can have multi-container combining into a single container. That kind of also you do. I did a lot of complex stuff. So just explore this. I mean, there are limited possibilities in Docker. And once you are done with that, you want to explore with Kubernetes, let's go ahead. That's a huge opportunity. That's a huge job ground right now. I'm getting offers from here, California, this and that. I'm not interested in you, but I'm getting it. So if you have good skill, you can also get this kind of opportunities. Now it's time to take some questions. Sorry. Okay, so John saying that in Kubernetes, what kind of installation you use in production, whether by kubetm and kubes. Now, this is the one you actually have to try it out, the most comfortable one. I use the kubes one that worked fine. Kubeadmin, for normal kubeadmin, I did some certificate installation, then I used. Now, see, Docker Compose is different from the Docker multi-stage. Let me show you the question. So John saying instead of multi-stage build, can you use Docker Compose? No, Docker Compose is for different thing. Docker Compose, you have multiple separate images that you are running separately and then linking in the application. That's separate stuff. That's kind of logical separation, and then using the logical name references to communicate between the multiple services. That you can do the same thing in ECS using maybe load balancers or maybe that is, what is that called? Networking stuff is there. You can do that way. Now in the Kubernetes, you can do by the pod naming and service names or service URLs. You can do it. So you can do that way, but these are different. I mean, in suppose any if I give you example, let me give you example that will be much more better. Like multi-service, you already saw the links. Now Docker Compose, how it looks. Docker Compose example. Example Compose, where it is. I want to show the Docker Compose complex any examples. Practical introduction Docker Compose. I think this one will be good. I want to give an example that how the Docker Compose look. Just give me a moment. This one is good example. So Docker Compose. Now I share the link. Just give me one moment. Okay, it's here. So Docker Compose, read this article. I'm actually sharing also to explain you why what I'm trying to say. That's a very good question, by the way. John asked a very good question. That why multi-stage build is different from the Docker Compose. That's a very good question. Okay, let me just share the screen. Chrome tab, like Docker Compose. Now, what is Docker Compose? Docker Compose ultimately is a YAML file. If you install Docker Desktop or Docker, normal one, or just use a Docker Compose. There is a simple separate binary also. You can just install it. After you install it, it gives you some certain commands you can use with it. Okay, now see this example. The current version, suppose the version is 3, and here see services they're mentioning. Result build, worker build, Redis, they're building Redis, DB is Postgres DB. They're running multiple images. They're not building using staging build in single image. Instead, they're just linking the services. Like there's a maybe board application in Python. They're showing they're serving the result dashboard in Node.js. They're doing like worker in Redis worker is running for the like maybe that publish subscription part. They're doing it. The pops up part actually. Now they're using Redis, Alpine, for vector. See, they're linking the networks here, and they have a Postgres image where they're storing the ultimate final images. So think about they're linking the multiple images in Docker Compose. They're not using a single image to build the final image. That is the difference here. Very fine difference, you can say. See, ultimately you have commands like Docker Compose. After this Docker Compose file you're done with, you just use the Docker up command, and it will, if it's the image is not there, it will build in and run it. If it's already there, and it will just running it. If you want to build the images, then use Docker Compose space build. And if you want to build particular service, then Docker Compose build particular service name. It will run like that way. I think in the end, see, this is they are giving already. Yeah, this is how they're doing it. So Docker Compose is good thing. I mean, but in the production, you don't use normally Docker Compose. You go for the Kubernetes or ECS kind of solution. This kind of are more advanced features, to be honest, to me. Okay. I think we talked about pretty advanced stuff this time. Okay. It was fundamental session, it's supposed to be, but ask questions. Ask good questions that will make me share more knowledge to you. I have knowledge, and I'm thinking what I could be giving you more complex knowledge. So that's why I'm not giving too much of it. Just simple intros, just simple concept stuff, what I'm doing in daily lives and all. Now I use Docker for multiple use cases. Now I talk about the use cases, right? Isn't it? Now, what are the use cases? Think about it. Think about it. Suppose you have a Node.js application, you have a Python application, you have some other kind of application. Now think about it. If you are running in a single EC2 instance or single machine, you are running everything in a single machine, and things getting cluttered, isn't it? It's not good solution. It's not proper. Okay. And sometimes what happens, the machine become very processing become overloaded, and ultimately machine become hang. Customer get issues. You face you have sleepless nights. Normally I used to have in the beginning days. Now I don't have it. So what you do, you containerize the application in separate container. Like for Python, this is the container. This is for container for Node.js. This is for Go. Can have many things, right? Think about the main strategy. This is the main strategy I'm talking about. So You have multiple application running a separate image. You can, for a separate image, you can have, say, logical separation using load balancer, or just separate load balancer for separate applications, and then communicate via, maybe just link the domain with them, subdomains. So they're like Node app, like say Python app, like say Go app, kind of subdomains you can do, and then communicate with them. Or you can use logical separation using the service mesh, and just logically separate the naming and communicate by the application. That's how you do it. You don't have to run everything in a single image and finally get tension and the scaling. Now the problem is will come not the initial level. You will see the scaling parts. You are scaling, but your application, ultimately the cluttered application, ultimately is not improving any performance. Suppose, now think about another stuff. Suppose you have an application for Node.js part, it's need more process. People are accessing more of it, not the Python, not the Go. There may be eventual one. So for that, you just need one machine, or maybe think about logical separation, one container. For the Node part, you need 10 container. But if you're running a single machine, you have to run 10 machines for that, or maybe 6 machines for that. That's not logical way. That's problematic, to be honest. What you can do using ECS or EKS kind of, if suppose it's EKS, then you run 10 pods for Node, you run one pod for Python, one pod for Go. If it's ECS, you run one task for Python, you run one task for this Go, and run 10 tasks for the Node.js application. That's how you will achieve more complex kind of architecture. Okay. Think about this kind of things, because this is very required. This is the practical use cases I used to do all the time. That's what I'm saying. When you have multiple, multiple application architecture, then you can do this kind of stuffs. That will make your life a lot easier, to be honest. Think about it now. Think about the use case more. Now there are a lot of use case, to be honest. Now these days the IoT, I think you're already hearing about the IoT age. So what is IoT age? Let me give from my concept part, that you are developing the application in a Docker container, maybe OpenWRT, or maybe it could be anything. It could be any container image. There you make your application logic there, everything there. Then it's doing the communication with kernel and all, doing all object stuff. Your application is in the container, and you are using that container, that image, and just distributing to any person. Now, since it's running in a particular container, it's going to run same way in any hardware. That kind of virtualization goal you can achieve if you go for the IoT edge using the Docker containerization. So think about this stuff. Now these days, if you think about it, these days you have unlimited kind of memory, you have unlimited computer. Even if it's IoT, you have enough CPU, enough GPU, or enough computing capabilities. Previously, you don't used to have it. That time, I think that was necessary. But now, since you have virtualization, you have this kind of good memory and good processing things. This is possible to do via this kind of IoT edge using Dockerization and all. Okay. Now let me take a question that is Kiran saying that, is it a good solution to keep web server, application, and database in different containers? If so, how do they communicate between them? Now, this is the good solution. This is how people do. You should not have single point of failure. If you run everything single place, if anything fails, everything fails. Okay, so never give the option for single point of failure. Think about the fault tolerance, think about the high availability, high scalability complex, think of concepts. There, if you have the application server, run the applications different, like normally do. For the web server is Nginx usually. So run Nginx server separately, use the proxy pass, and run the application just proxy pass to another container. So how you can do it? You can use the load balancing. You can do the that is inter server. Some private domain base. You can use what is it? Cloud maps. You can use the cloud maps for the private service mesh. You can use the service mesh also. There's a lot of way. Load balancing, service mesh, domain. You can just assign the domain to a particular that load balancer. You can buy the domain. Multiple solutions there, but it is good solution to have the application, the web server, and the DB server in a separate container. That's a very good part. Okay, do that way. I suggest that one actually. I never run everything in a single place. In the beginning of phase, I was used to run it and think one thing go crazy, everything go crazy. That was a nightmare. So never do that way. Suppose in the container part also, suppose a container running all good, suddenly something happen. It can always happen. Now the storage part, suppose say storage part is consistent. Suppose a persistent storage, you no problem. So whenever the next container come, it will use the same. Suppose one container down, there is some health check going on. According to health check, new container will come up eventually. That will use the existing separate container. So no problem in this architecture. Okay. Any questions? So yeah, if you any have anyone any question, if you have it, just let me know. I'll be answering. No problem. I actually used to run all these kind of separate applications separately. I never merged this. That's very nightmare managing all these kind of applications. To be honest, at the beginning of it, I used to do it, but that's not a good idea. I got the problem. Then I understand. Okay, no, don't go this way. It will make your life a lot tougher. That time onwards, I was going normally only, like separate container, separate image. Do that way. Okay. Sandip, good vibes. Thanks, Praful. So anyone have any questions, you can ask me. I have 10 minutes. In the 8:30, I will end the session. So if anyone have any questions, they can ask me. We talk about a lot of topics. You should have any questions, right? So ask me, no problem. I will be answering them. In LinkedIn, you people ask a lot of questions. I don't get time. Now you have opportunity. Like ask me any question, I will give you answer live. Actually, one person asked me one question. Let me answer that one. Saw it. The question was, okay, warehouse connection. Okay, so any idea how to? It was like Abir Pal saying, I need your help. I want to build a warehouse management software, kind of CRM software. Like it has to be used in a warehouse of a hospital. So may I know any idea how to get started on this, like using Node.js, Express, and what I can do? Please help me. Now, the basic thing, you have to get started. If you think about all these complex stuffs, where to get started and all, you never get started. So first think about what your resources are. It's Node.js, you have available Node.js developers, or you have the knowledge in Node.js, or what programming language you have knowledge. So using that only you have to get started. Think about what kind of framework you want to choose. You want to go for just Express, like Express default framework. If not, then you should be using the Next, or there is Happy, there is Koa, there is Sales. I like the Sales.js part. You can try it out. That way, more thing will be easier one. Like for the database, you want to use the MySQL or the MongoDB. Suppose you want to use the MySQL, and think about using the SQLite package with Node.js. If you want to do MongoDB, then think about using the Mongoose package with Node.js. This kind of stuff are there. Start with the cloud application first, then make it big, slowly. Think about the application architecture, because in the beginning you normally, but in the long run, if you want to, you have a big application, then onwards it will require to have a good architecture application. How you'll understand this good application architecture? Check for the boilerplate. If you go to just GitHub, you search for the boilerplate. Think about the star. How many stars that boilerplate got? The more stars, more efficient the boilerplate is. That's my logic. I choose that way in the initial phase. Now I have my own framework, but that time I used to select like that. Okay, so thinking about that way. Okay, I think I answered one. Okay, any questions? Later future validation. Okay. I think Docker I have covered. ECS, EKS I've covered about that. I think covered most of it. Now these are the fundamentals, to be honest. You want to get, first you have to know Docker. Docker, then you get started with this kind of stuff. So in Docker, what should be learning? Let me talk about, since I have 5 minutes time, I'll be talking about the Docker learning process. How should you learn Docker? First, learn the Docker basic commands. Like use the Docker, do Docker pull. That is the basic command you should be doing first. Pull the Nginx image, run the Nginx image, like Docker run, then the Nginx, like that way you run it. Then do exec, like log in your application, see where things, how things are working, how things are doing. Like run some commands, install some packages manually. Then extend that to So run that, extend that to with your own application logic. Like your application could be something else, right? That you want to run in a like it's a Node.js application. You do a proxy passing in a different port, and you are running in and you are exposing the public like port 80 or port 443 to the whole world. This kind of simple kind of try to do and learn it, run the application. Then come this multi-stage build, all this kind of Docker compose, this and that. Then come it, no problem. But start basic, play with the Docker commands. If you just go to my playlist, it's starting with the basic commands and everything. Start from there, and slowly you will keep learning and learning. And after you are confident enough in Docker, then go for this ECS, EKS, all this kind of complex stuff. Not only I'm talking about AWS, but if you go to the GKE or AKS, that's all fine. And learn from the basics. Start with the basics, then go to complex stuffs. That is the important part. Okay, Chirag saying something. Would you like to share on Kate's future now? Kates have a very bright future. You are already seeing it, right? People are going crazy over Kates. Tinder, you say about Airbnb, they all already moved to Kates. Why? Because it giving them all the modern requirements. They have modern requirements which need the modern solution. Kubernetes, you have a lot of plugins, you have a lot of infrastructure available, you have a lot of open solutions. If something is not there, you just build plugins and do all this kind of stuff. There is there. You can do it. It's widely adapted. There is huge communities there. Logical separations using the application. You can do all complex stuff in using Kubernetes. So Kate's future is already is there. So don't worry. It's a very good one. As a future choice, if you are suppose someone want to have a future in Kubernetes administrator or Kubernetes application developer, you have huge chance. At least say 5-6 years, you don't have to worry about job with any problem. If you have good knowledge, you got the experience, there will be no problem in getting job, and no problem at all. Just go ahead with it. Okay. Istio is the service part, and Istio is good, but sometimes it's become too complicated for me even it's to understand. So initially I was learning Istio and I was like, wow, what is happening? Then I keep using it, then I had to go to know. The beginning is tough, but if you think about the service and more kind of traffic balancing and all this kind of complex stuff, Istio is good. Learn it properly, learn its focus, and then Istio is good enough. It will handle a lot of canary stuff, shadow placements, the service complex service topologies you can do via the Istio. Okay, is AWS compatible with containerization technologies like Podman, Rocket? I'm not sure with it because I didn't use the Podman or Rocket. But since you told me that, I will be checking out. Maybe some future post I will be sharing about that. But Vinayak, that's a very good question. Podman and Rocket, I'll be checking them. I don't know. You can just Google about it. But maybe since you told me, I will be checking and sharing my knowledge on that also. Okay. It would be great if a new EKS video will be availability. Yeah, I'll be doing the EKS video very soon. Maybe not this week, because this week I have to release the serverless application first, because I promised to my viewers and the followers also that I'll be doing the serverless with DynamoDB, Lambda, Node.js serverless framework. That I'll be doing. Maybe tomorrow afternoon I'll be finishing that. I started initially, then got busy this and that, meetings and all stuff. So I didn't able to complete, but I will be doing that. Maybe next week I will try within next 1 or 2 weeks. I'll be trying to make a new EKS video. Don't worry. Okay, that's the end of the session. If anyone have any kind of question, just ask me in the normal comment section or reach out to me on LinkedIn. I'll be helping. No problem on that. Okay. So thanks everyone staying all this longs. If you have any questions, you can ask me anytime. Okay. Bye then.